As I already told that we will be learning about the sensors and actuators. Sensors are nothing but input devices which act as an input device for a microcontroller. If you are designing any circuit, like if you are using any microcontroller to give any input to that microcontroller, you can use sensors. So basically, sensors acts as an input devices, and we have actuators which acts as an output device, like which indicates what is the output of your microcontroller. So indication of output will be given by the actuators. So examples of actuators are relays. So relays, motors, and there are many examples. So let us see what is a sensor. A sensor which converts a physical phenomena into a measurable analog voltage. So analog voltage, or it can be a digital signal which is converted into a human readable display or transmitted for a reading or further processing. So whatever physical phenomena is there, that is converted into an analog voltage. The physical phenomena can be input like signals. It can be any signal. So that signal can be converted into an analog voltage or a digital voltage. Analog voltage means it can vary from like minus infinity to infinity. And digital means it will be having only two values, 0 and 1. 0 means low value and 1 is a high value. So it converts any physical phenomena into an analog or voltage signal, which is which is in terms of human readable form. So you can read the output. And for this sensor, we have selected this IR sensor. IR stands for infrared. So infrared sensor is an electronic device that emits, like which emits infrared rays in order to sense some aspects of the surrounding. This IR sensor is used for detecting the objects which detects by emitting the like infrared rays. It can measure the heat of the object as well as it detects the motion. It also detects the heat of an object, and it can also measure the like motion, like it can detect the motion of that object. And infrared radiations are invisible to our eyes. So you can't see that infrared rays which can be detected by an infrared sensor. So to detect that infrared rays, an infrared sensor is used. The emitter is simply an IR LED. To emit the IR rays, an IR LED is used which emits the IR rays, and the detector is simply an IR photodiode. To detect the IR rays, we are using a IR photodiode that is sensitive to IR light of the same wavelength as that emitted by the IR LED. The basic principle of this IR sensor is it there will be like two uh, main points. One is an emitter and one is a receiver. Emitter which emits the IR rays, and receiver which receives that IR rays, and it gives an output according to the received signal. So when an IR light falls on the photodiode, the resistance and the output voltage will change in proportion to the magnitude of the IR light received. Whatever like signal received by this photodiode, according to that, the like it will be directly proportional to that signals falling onto it. If the higher the rate of the signal falling rate, the more will be the photodiode output, like that. It will be directly proportional. In this diagram, you can see that this is the IR LED which is emitting IR rays. So if an object is present, like if object is there, these IR LED, like these IR rays are reflected back, and that reflected rays are captured by this photodiode. Hence, the output of this photodiode will be high. So this is the working principle. There are components used are LM358 IC. This is an LM358. This is an op-amp which acts as a comparator here to compare the inputs of inverting as well as non-inverting terminals. The resistance of range of kilo ohms. There are like three resistance and variable resistor, that is a potentiometer, and we have used a LED. This is an LED to indicate the output of this IR sensor, whether the output is high or low. Is it clear? Hello?
Yes, ma'am.
Okay. So when IR receiver does not receive a signal, the potential at the inverting input goes higher. This is a inverting input. Negative terminal indicates the inverting input, and positive is a non-inverting. So if there is no signal, then the non like inverting input goes higher than the non-inverting terminal. Hence, the output will be low. In that case, the LED will not turn on. If the receiving signal potential at the inverting input goes low, like if there is any signal, the output will be high. Hence, the LED will be turned on. Like in this fashion, the this comparator works. It just compares both the inputs and gives a high-low input. So we have an actuator here, that is a 5-volt relay circuit. The electromechanical relay is an output device. The relay are switches that open and close the circuit electromagnetically or electronically. So a relay acts as a switch which turns on or off an electric component. You can connect many components to this relay. So if relay is off, whatever components connected to this relay will be turned off. So relay just act as a switch here. So we will be designing these both sensors and relays. The output of this sensor will be given to an input to this relay. So if the sensor is high, the output of the sensor is high, the relay will turn on or turn off according to the like programming, whatever you are doing. You can use a microcontroller like Arduino. So if the relay is turned on or off, according to that, the relay will be working. So any doubts in this part?
No.
Okay. So we'll go for the schematic and the layout part. Let us name this schematic as project as a IR sensor and relay module. Save this. Change the sheet as a schematic. And save the schematic. Firstly, to give an input to the sensor, we will need a DC power supply. In last class, I shown you how to design a DC power supply unit. So this is my DC power supply unit. So I will copy this unit here. This is the major like use of this easy tool. You can copy paste any circuit from this circuit and you can paste into the other circuit. Just select that unit and press Ctrl C or press right click. And there is option called copy. And you can go to your schematic and paste it wherever you want. This is the use of this easy day. No need to design the same circuit again and again. You can do a copy paste here. This is the DC power supply, which will be given as a input to our IR sensor as well as our relay. So for the working of the relay and IR sensor, we need this DC power supply. So in case of IR sensor, as I have shown you the design, according to that, I will select the components. Firstly, we need an IR LED and photodiode. So you will not find that in E library. So you need to go for global library and search for IR LED. You have already seen how that IR LED looks. So according to that symbol, you need to select here. Yeah, this looks similar. Don't select an SMD component. You need to select a through hole component which has holes. It can be selected, it has holes. So I will select this IR LED and I will place here. So see the orientation as well, how it is placed. It has two terminals, cathode and anode. So this the line indicates a cathode and this is an anode. So anode is facing upwards. So you need to rotate it and place it like this. And we need an photodiode. So just type photodiode. Again, go to the symbol, how it looks. According to that, select the symbol here. The selecting this symbol will make your decision should be like proper. If you select a different components, your schematic will go wrong. Output will not be as you expected. So select a through hole photodiode. These all are symbols. It has no any footprint here. So I'm searching for the photodiode which has footprints. So it has a footprint and it is a through hole component. So I am selecting it. Again, go to the circuit diagram and see how the placement of this component has done. Again, the cathode part is facing upwards. So just rotate it and place it like this. And we need two resistors. You can
Ma'am,
select
the arrow is in another direction.
it's same, right? The cathode is facing upwards.
And the arrow?
These arrows,
These arrows should not be same.
arrows can be same because I don't know why they have like shown like this. Actually, photodiode receives the IR LEDs. The arrows should be facing towards this component. So let us find. We will find that or no. It it is the correct symbol, but it has no footprint here. You can select this. It has both footprint and symbol.
Okay.
And select the two resistors. So my resistor values are 110K. Let me place it first. I need a potentiometer and LM358 comparator. So the potentiometer is present here. This is your potentiometer. You can select that. The potentiometer is nothing but a variable resistor. You can vary the resistance of this potentiometer. It has a knob. You can rotate that knob and the resistance will increase or decrease according to the rotation. I need a comparator, that is LM358. If you want to see the working principle of this LM358, you can search for this data sheet and you can see how it looks and all. It will be having two inbuilt op amps into it. So let me see. There, like it comes in two ways. The one with a proper symbol, it looks like an amplifier, or it can be like this. The what like it has a rectangular shape and it has 8 pins, 4 pins on each side. You can select this one, or if you want the exact this one, you can go for that also. And this is how it looks. Just search for the one component which has both footprint and like both footprint and the symbol. It has footprint, but it has not all the pins. So let us search for the better component. You can select this one. It shows all the pins here and it has all the component like pins also. I will select this. Before that, see how it is there, like positive terminal on upper side and negative terminal is on the lower side, but it has like positive terminal on the lower side and the negative terminal on the upper side. So if you don't want to get confused, you can select the one which is shown here, or you can flip this like all the connections in your circuit. I got the one with positive, but it has SMD. Okay, you can select this. Okay. Again, it has negative terminal. Okay, let us select this one only. It is a proper one, but make sure that you are connecting like negative and positive terminals correctly. And again, I need one more resistor and LED. For that, I will select a resistor and I will search in LED here. Now let us make the connections. My 5-volt input is given to this IR LED photodiode as well as the potentiometer. Got these all. This 8th terminal is also connected to 5 volt. So I will connect this one here. And our 4th terminal is connected to ground. So it has to be connected to ground here. And this potentiometer terminal is connected to the inverting terminal. Negative indicates the inverting terminal. So my inverting terminal is second pin. So I have given here. And this positive terminal is connected to the junction of this photodiode and the resistor. So these are the connections. So this input is given by my DC power supply.
Ma'am, fourth pin is not connected.
Okay, thanks for reminding. If you get confused whether the connection is done properly or not, you can drag that component and see whether the connection is moving or not. If it is not moving, then you need to do a proper connection again. So this input is given by this DC power supply. The output of this is given as V in. So again we will select this net label and we will place it here. Make sure that it has a one positive symbol. It has to be placed on this wire. Then only they will be internally connected. 1 second, I will be back. Okay, sorry for the disturbance. So it is, we will rename it as V in. The same name has to be given here, whatever you have given as output pin here. Yeah,
Ma'am, screen is fixed.
okay, the input is given. Now it has to be connected to ground. You can take this ground, copy this and paste it here.
Ma'am, which pin you have taken?
This one. The DC, whatever output coming from your DC power supply unit, that has to be provided to this, like as an input to your sensor.
I means this is a wire only. In the second part, pin is a wire only.
I am not understanding what you are saying.
Means how did you drawn this part? Vein? Just a wire.
Yeah, this is a wire. This is a wire, but this is a net label.
Means
In
how did you
the
net
in the
label?
last class, yeah, this is there here in wiring tool. You
Can you
can
repeat the
press
part that
N.
screen was frozen? Can you repeat this part?
Okay, okay. For the net label, is it now visible, right?
Yes, yes.
Yeah, this is the net label. You can press N in your keyboard. That is a shortcut, or you can go to this wiring tool and select this net label. And it has like a positive symbol here, which has to be placed on this wire. Then only the internal connection will be done in between your power supply and sensor. Okay, you can see that that positive terminal is placed on this wire, and don't place at the extreme end, just place in between, and rename this net label as V in. You can rename whatever name you have given here. If it is a 5 volt, you have to rename it as 5 volt only. Whatever the output you are naming here, the same has to be named here as an input.
Okay.
So this is my sensor part, and the first terminal will be my output. So that output I am going to provide as an input to my actuator. So I will again name it here. Like you can name it as a relay, so that it will be given as an input to your relay. So my relay, I will just show you how to draw a relay circuit as I have shown you here. It has a 5 volt relay, and it has again a NPN transistor, a diode, and some resistors. So whatever circuit I am drawing, it is a relay which is acting as a switch. For a relay, you have to go for the global library and type as a relay, and search a relay. Yeah, this is a proper one which has five pins. You can select that. We have a diode. The part name of diode is 1N4007. The second one you have to select, which has a through hole footprint. So select that one, and again go to the symbol, check how the diode has placed, and again it has two terminals P and N. This line indicates the N terminal and this triangle indicates P terminal. You have to rotate this, and again connect them. And we need a NPN transistor. So I guess it is not there in my library. It is there, I guess. It is NPN transistor with SOT TU. Let me search in library only. The part number of NPN transistor is 2N22. So this is how this NPN transistor looks. The arrow will be like facing downwards. Select any component with a proper footprint. I will select this one only. That has to be placed here. And again, we will
Ma'am, this
provide.
one is not SMT component.
No, all are through hole only.
Means how to
In,
understand that this is not through hole or this is SMD?
in case of your footprint, if it has a hole, then it is a through hole component, or it has a pad, red color pad. Let me show you.
Ma'am, this one is SMD or through hole?
It's through hole. You can see the holes here, right?
Okay. So we can pick this one also.
Yeah, you can. The one with the red rectangular shape will be the pad, and it is called a SMD component. That is surface mount device.
Okay. The pads
So
will be only on red color.
yeah, it will be shown in red color only. And again, we are connecting a resistor and a LED. Just to show whether my input to like my output of this relay is high or low. And to filter the signal, we will connect a small capacitor, a ceramic capacitor of zero point 0.1 microfarad. So this here the input has to be given. The input will be the output of your sensor. Again, you need to select a net flag and place that net flag onto this wire. By default, it will show you the like text of the previous one. As you have named the previous label as relay, it will show you the current label as a relay also. So you have to place that on this wire. Again, don't like place on this at the edge. Make sure that this red flag is placed properly. If it is not placed, the components will not be connected internally. Okay, again, I need a ground here. And my input is also given here. So you can again select this net label and place on this wire and rename it as V in. So these two wires will be internally connected now. Now these are my outputs like switch relay outputs. I will connect them to a connector. This is an header. HDR indicates header. I need a connector. CONN indicates a connector. So I need a 3-pin connector. So I will select a 3-pin. You can see here 2P indicates a 2-pin, 3P indicates a 3-pin. So select a 3-pin connector and connect. So if you want to get like these three terminals at the same time, you can connect a header. So the header is here. I need 1x3 header, and I can connect this V in to my first pin, and you can connect an output here, and you can connect a ground pin here. So you no need to search for the inputs, you can get directly here. Before that, you need to go to the like IR sensor model. Let me see how the pins are connected. This is the IR sensor. So it has three headers. One is VCC, one is ground, and one is output. So they have given first pin as a VCC, second is a ground, and third is a output pin. According to that only I will give. First is a V in, second will be my ground. So second pin is ground, and third is output pin. This is my output pin that I will connect to this third pin, and this is my ground pin. I will sort here. So this is how your IR sensor is connected to your relay. Let me place them properly and give them proper names like block names. You can again like subdivide them as a subcircuits. Again, select a rectangular box from the drawing tool. And place a rectangular for both of them. To rotate all the components, you can use this arrows, left arrow or right arrow. So I will make it as a dashed one. So name this circuit in text. can name it as a IR sensor and relay integrated module.
Ma'am, in the header, why is the order like this? 1, 3, 2.
As I told you that in this IR, this is the IR sensor, how it is looks. Okay. And you can see this as a VCC pin as a first pin, and this is a ground. I guess it is not visible for you right now,
Okay, okay.
but you can see when you are actually using them. It has first pin as a VCC, second as a ground, and third as a output pin. Okay. So in my schematic, this first pin is a input, whatever input I am giving here. And second is my ground, third is my output.
Is it a connector, ma'am?
This is a header. This is the pin like structure is a header.
Okay.
Like it has male headers and female headers. This
Okay.
is a male header, and the one which I have selected here is a female header. Because in my e-library I don't have male header, so I have selected a female header.
Okay, okay.
So you can increase the font size and reduce the schematic size and all, and place them like little closer. You can fit this schematic in a smaller size. Okay. Again, save your schematic. So if you want, you can take the snap of this circuit and try to design the schematic. We will design the layout in the next class.
Okay, ma'am.
So do you have any doubts or any queries?
No.
Okay. So try to design this circuit as well as the one as I have already discussed in last class, that is multi power supply.
Ma'am, please upload the previous session.
Yeah, I will again tell